So we have another reliable pressure sensor, which is the strain gauge. Okay, the strain gauge. The strain gauge is usually made up of a very thin wire material, thin material, and we know that resistance of a wire is equal to rho L over A, where rho is the resistivity of the wire and L is the length of the wire, A is the cross-sectional area of the wire. Are we getting it? So now, on the strain gauge in the sensor, the L is fixed, as you can see on the right. The length of the strain gauge is fixed. Okay, so as you exert pressure into the strain gauge, you see that the strain gauge is capable of stretching. Remember, the length is fixed. As it's stretching like that, it thins out. Okay, so as it thins out, what do you think will then happen to the resistance of the strain gauge? Let's look at the formula again. R is equal to rho L over A. So as it's thinning out, what happens to A? A is reducing. Okay, so when you look at that relation, R is equal to rho L over A, it means that the resistance will do what? Will increase. Are we getting it? So this strip of wire, this strain gauge, is connected to a Wheatstone bridge. At no pressure, we have the zero voltage out. Okay, remember our Wheatstone bridge experiment with the galvanometer while in secondary school or college. Okay, high school, I mean to say, not college. So the Wheatstone bridge experiment, okay. So you see that it is calibrated such that all of these resistance selections, okay, they are done. Remember, this is it. Okay, all of these resistance selection, they are done such that the output from here is okay, the output from here is zero when you have your normal supply voltage, which is this excitation voltage, as you can see here. Okay, so once it is stretched, you see that the balance on the Wheatstone bridge will be affected. Okay, because this resistance have changed or increased, so that will cause voltage to flow at this so the amount of voltage that will flow here depends on the change that we have here. Okay, so you see that the meter reading will be calibrated to give us a direct reading of the pressure that will cause that change. Okay, so this is an example of the sensor. Here is subjected to the here is connected to the process. The process fluid stretches the diaphragm. Okay, we have the Wheatstone bridge, the power supply and the outputs, they come in through these cables. Okay, and then this is fed into the system that will give us either a direct reading or for control purpose. Okay, so these are pressure transmitters. The pressure transmitters, what they do is that they receive signals, okay, from the sensor that is on the line. Okay, see, this is an impulse line. Okay, okay, the sensor is here. Okay, receive the sensor from the okay, receive signal from the sensor, and then it amplifies it. Are we getting it? And then transmit it to, so it is what we now amplify it to this 4 to 20 milliamp value that will be transmitted either for control or for monitoring purposes. Okay, so the transmitter is basically an amplifier and a transmitter, so to say. it amplifies and send the amplified result to where that result will be used. So these are examples of pressure transmitters. Okay. So in most designs these days, we have both the sensor and the transmitter in a single transmitter unit. Okay, like we have here. Okay, this is a DP. We'll see it later. Differential pressure transmitter. Okay, so this is the impulse line that is subjected to that brings the process fluid, and the pressure on this line is the same with that in your process. Okay, so these are wireless transmitters. As you can see, these are transmitters with wire, okay, that can send the 4 to 20 milliamp signal to your controller or to your control room, as the case may be. So here is a complete configuration of the process, the pressure sensor here, okay, the transmitter that sends the signal to your controller, then your controller to your final control element, which is the valve. Okay, so it is basically to this one is basically to control flow, and as the flow is controlled, the pressure is monitored. If the pressure is high on the upstream, that is upstream this valve, okay, flow could be increased to reduce this pressure. Are we getting it? So this is a pressure switch. Pressure builds up to a stage. The switch is energized, okay, and then the valve is meant to open up. So this is a transmitter as you are seeing on your screen, okay. So next we'll move to temperature. But before we do that, let's take a brief break.